Like I said, my name is Shannon Rosaire. We are recording a lot of these sessions. We are recording this session and we will make them available after the conference so you can have access to some of this information. This is a Zoom meeting, so please make sure you're muted. If you are sharing your camera, that's wonderful. We love having you share your camera. Feel free to post questions in the chat window throughout. Like I said, I will be monitoring the chat window. Dallin will be presenting. We'll kind of see how it goes. We may do some questions throughout the call today. We may save them till the end, so we'll go from there. And then Dallin, I'm going to just stop sharing my screen so people can just look at you.
Thank you. This is the first time I've ever tried to share my screen in Zoom, so we'll see how it goes. Share. And let's present. Did that work? Does everyone see my screen? Yeah, please, hopefully.
Yes. We say, hi, I'm Dallin.
Good. Okay, cool. Hi, I'm Dallin. Welcome to Kuali Days. Hope you guys are all having a great time here. My name is Dallin. I've been at Kuali for 7 years now. And currently I'm an engineer on the build team, which it's been a fantastic time. I love this product. It's been a lot of fun to work on. And we're going to talk about GraphQL today. And before we get into it, I just want to give a little overview of what we're talking about. It's going to be a pretty data heavy talk. So luckily this is recorded. You come back and watch it anytime. We're going to go through like 3 different parts of GraphQL. The first is we're going to focus on the history of like what came before GraphQL, why did we choose GraphQL, like what were the motivating factors there. And the second part is what is GraphQL, and the third is going to be how do we use GraphQL here at Kuali. So here's a typical web app, right? You've got your database, your web server, and your clients. And I believe the data is probably the most important part of your app. And the server is really there just to be a steward of that data and to let the right authorized users in to use that data, because data that is not being used or viewed isn't really worth much. And so this talk is really focused on this part, right? How do clients connect to the server so they can communicate, manage, and use the data that you have? In the past, we've been using REST as one of the common protocols. And it's a pretty simple protocol, right? It's tied directly to HTTP. With REST, you have a set of resources. You divide your data into resources. Those resources end up on the HTTP path. And what you want to do to that resource ends up in the HTTP verb. So if you want to create, read, update, or delete something, that ends up being a post, get, put, patch, or delete against that resource. So some examples would be, want to create an account, that'll be a post to /accounts. Want to fetch a user, it's a get to /users, right? Delete a document, a delete to /documents/id. And this works for a lot of things. But oftentimes your business processes don't fit one-to-one with these REST calls. And so you kind of have to start like shoehorning your stuff into REST. So here's some examples. Login. Technically, when you log in, you're creating a new session. So technically this should be a post to /sessions, but if you ever see that in API docs, it's not as clear as login. Like a post or a get to /login, which is what you often see, is way more clear than post to /sessions, but it's not as pure REST as the other one. Canceling an order could be a delete to /orders / an order number if you're actually deleting the order, or it could be a put if you're keeping the order around, but you're updating it and putting a cancel flag set to true. And that's kind of a problem because your implementation details are leaking out towards your clients. And then generating a token sounds pretty simple, but like, right, it's generate, that's a create. So you're posting the /tokens, but tokens belong to a user. So is that a post to /tokens with a query param for the user, or is it a post to like users, the user ID, and tokens as like a sub resource? So you kind of got to like massage your data into this REST stuff. All that stuff all works, but it can be clear in a different way, right? We have calls at Kuali for like simulate workflow or approve step or um, initialize workflow that would be pretty difficult for us to figure out where they fit in the REST world. This is overcomable. The two main problems we found with REST are overfetching and underfetching. Overfetching is when you're getting back more data than you need. So in this example, if we're getting back a list of users, we do a get to users. You might, you're running a script, you might just need the user's emails. Or if you're building a page, you might just need a list of the user names so that you can have a list of users. They click on one, it goes to a detail page. But you're not getting just the ID, name, and email. You're getting phone number and birthday and just everything that exists on this user object. So that's what we mean by overfetching. And these objects typically grow. Like we end up needing more data about a user, or so to make a page work, we'll have extra data added to that page. Like at the very bottom, you might see this new form UI enabled is true. Almost nothing that hits users is going to need that, except for the one page that has the new forms UI. But as soon as you add these fields, it's really hard to get rid of them from an object because that's a breaking change. You don't know who's depending on this stuff. So these objects just kind of grow and grow and you get everything. And it's not a terrible thing. It's just not as efficient, not as performant to be fetching all of this data. And underfetching is the other problem, where if overfetching is you're getting too much data, underfetching is you're not getting enough. And this is also called the N+1 problem. And when I say not getting enough, I mean you don't get enough data, so you then need to make subsequent requests to get the rest of the data that you need. And a good example of this is if you want to get this chain right here, you've got users, you want to see their friends, and you want to see those friends' posts and those post comments. Odds are you're not going to have a single REST endpoint to get all this data in one call, right? You're going to have to hit the user's endpoint and iterate over that data to find those users' friends, and then send off a bunch more requests. And once you get the friends, you're going to have to iterate over that data to find their posts and then the comments. And you could end up doing hundreds of requests just to get all the data that you need. And this problem is solvable. I've seen it solved either by people kind of just ignore it and say, yeah, we'll take the performance hit, or they kind of deviate a bit from REST and they end up making endpoints in their server just to fetch all the data for a page instead of for a resource. It kind of just evolves and grows into that, where you say, well, we have a user needs to be fetched for the dashboard page and we need these fields. But when the user is fetched for the birthday page, we need these fields. And you end up with two user endpoints. And really, they're just an endpoint for the dashboard page and an endpoint for the birthday page, which is great if you're building an app. Not so great if you're going to be a third-party consumer of this server, because you can't write your own endpoints. You got to bug the developers to write those. So we think there's a better way, and that's GraphQL. GraphQL is a transport agnostic query language, and transport agnostic meaning like REST is very tied to HTTP. You got those HTTP verbs and then that path inside of REST. GraphQL is simply the query language. It is how you request data from a server. It can be done over HTTP, often is, but it could also be done over WebSockets or gRPC or email or snail mail if you really wanted to take out your pen and pencil or pencil and paper and write me a query. I don't recommend that. It'll take a long time. But the important part here is there's this query language that lets a client specify exactly what it needs from a server. The server can provide data and tell the client what it has, but the client is the one who says, I need this and that and this. So here's an example GraphQL query on the left side here. So we're asking for the logged in user, and we want that logged in user's name and their email. And on the right side, you'll see that's what we're going to get back. We're going to get back an object that has logged in user, and that object has name and email. So that's one really great property of GraphQL is the responses are very, very predictable. Like it looks almost identical to the query. So if your query succeeds, you know what you're going to get back. You can see here we didn't overfetch anything. A user actually has a lot of properties on it. We only needed a name and email, so we only asked for name and email, and that's what we got back. So that's an example of how overfetching would be solved. And then underfetching solved similarly. Like here, our query, we're asking for an app, and we want that app's name, and then we also want all the documents tied to that app. So in one request, we can fetch the app resource and a documents resource. And this is because GraphQL, while it also it describes what data is available on a server, more importantly, it describes the relationships between that data. Like your GraphQL server knows that apps contain documents. Those things are linked. You can now query them that way. This is also the first time you're seeing variables. Any field in your GraphQL query, and a field is like app or name or documents, any of those keys on the left side. Any field can have a set of parameters passed to it if the server supports that. So in our case, app accepts an ID of 789. You can have those things inlined, or you can parameterize those out of your query and pass those in separately. That's often what you'll do if you're doing a production query. The only caveat there is you notice all the queries we've done so far have had, they've been anonymous. They've had no name. If you're going to pass in variables, you do need that name. So here we've named the query A, and we'll cover that again in the next section. But that's just one caveat there. So that was queries. Queries are for fetching data, reading data. If you're going to create, update, or delete, do any like the modifying data, those are done in mutations. Only difference is you'll start the whole query with a mutation keyword instead of a query keyword. And here we call the mutation generate token. So let's go through this really quick first. Here's a mutation called generate token. It takes in the user ID. It sends back data. We can select what data we want back from the mutation. The mutation might send us back a full user object, but we only care about the name. So we're only going to select name off of the response. I think it's really awesome that like in GraphQL, it's called generate token. You can define these names. If we were going to cancel an order, it'd be called cancel order. But simulate workflow, we're going to call it simulate workflow. It's not going to be like a post to tokens and you have to figure out, were they generating a new one? Is it generating an old one? Like you don't lose any of that context because you have this human readable key of what you're doing. And now I know I should have said, GraphQL lets you get all of your data back in one single request. Everything you need, nothing more. But what if you needed to do something like this? You've got two distinct users that you want to pull back. You know their IDs. I've seen this commonly, like if you have two apps in build and you want to take all the data back from those two apps and kind of merge it together. You might know those two app IDs. You need to pull back both the apps in one query. Since the result always looks exactly like your query, we're going to try to pull back these two users and save them to the same key. JSON doesn't let you have duplicate keys, so you're going to lose something, right? Or maybe you'll get an error. Like I'm not actually sure what's going to happen. I just know that you're going to be sad. You've asked for two things, and you're not going to get those two things back. But GraphQL does support this, luckily, something called aliases. So aliases let you label your fields. So here's the exact same query, but we've labeled them Bubba and Alice. So now I am going to get back both users. And notice the first one is keyed by Bubba, the second one is keyed by Alice. So this is how you'd pull back, like perform the same query, like hit the same fields, user in both cases, and get them keyed differently so that you get all the data back. You may notice that this isn't super dry code because we're asking for the birthday and the cake flavor for both of these queries. And if this is some app that we decide, oh, we also need email on these users, I might add email to Bubba and forget to add it to Alice. So GraphQL offers something called fragments. I can create a fragment called bday, put birthday and cake flavor in that fragment, and apply that fragment to each of my queries. And now if I need a new field, I can add it into that fragment and it gets applied to both places. So fragments are nice for deduplication of these fields, but also really nice for if you are building an app, you can co-locate your data requirements with your component. And by that, I mean, if you have like a profile component and it's going to display a user's name, their email, and their profile picture, that profile component can also export a fragment of all the data it needs and manage that data itself. And whoever's rendering the profile component is in charge of also taking that fragment and applying it to a query somewhere. And you should also note on this fragment, we call it fragment bday on user. GraphQL is very strongly typed. You'll know ahead of time if your query will succeed or not, based on these strong types that the server provides. And sometimes you need to give GraphQL a couple hints. And so we had to tell the GraphQL, like, hey, we're creating a fragment. This fragment is meant to be applied on users. And now GraphQL knows, oh, yeah, user has a birthday and a cake flavor. This is valid. Continue on. Here are some examples, by the way, of like actual code we have that using that schema that GraphQL provides, that those strong types, we can validate our queries ahead of time. So in this first top left example, GraphQL knows that I misspelled one of my field names. I forgot an E. And it even says, did you mean display name? Yep, totally meant that. In the top right, I requested something. I requested tile options, but I forgot to request the subfields in the tile options. Like tile options by itself isn't valid. It's like requesting just user. GraphQL wants to know from you like what exact fields do you want. So I need to put curly braces there and ask for the specific fields on top of tile options. One nicety here is in build, we have some pretty decent caching, and we always cache objects by their ID. And we know based on the GraphQL schema what objects have IDs and which ones do not. And we know that a user has an ID. And so in this example in the bottom right, we know that someone tried to request a user and did not request the ID back as well. And we'll throw an error to the developer and tell them, hey, you need to actually put ID down because otherwise our caching is not going to work. So this really speeds up development for us. It helps fix all these issues and find them earlier on in the development process. And then our last one on the bottom left is an example of deprecated fields. And it even has our deprecation message there, the we now use ID-based URLs. So that query will still continue to work, but GraphQL allows you to deprecate fields when you're no longer using them. That message gets sent on to the consumers, and eventually you can get rid of that field once it is not being used anymore. And I just want to note, it is really nice to come into an app and see these GraphQL queries. I've come into an app before and seen, okay, we're fetching a user. Great. Okay, I know we have a user now. I have no idea what's on the user. I can guess. It probably has a name and an ID and an email, maybe. But with a GraphQL query, you can see exactly what data you're getting back. And so it helps onboard developers a lot quicker. They'll know what data they're working with ahead of time. And so speaking of deprecations and versioning, you'll often find that REST APIs are versioned, and it's often due to that overfetching problem. If you have a user's API and you keep adding fields to it, eventually you're no longer going to use some of the fields that you've added to the user, but you cannot safely remove those fields because that's a breaking change. And so eventually you get so much data on there that you decide, okay, we're going to make a V2 of users. It's going to be the smaller user object of all the things we need. And then we'll repeat that process of loading the user object until we make a V3. GraphQL helps you get around that problem. And you actually do not have versions in GraphQL. So because you have to specify exactly what fields you want back, I can be confident that when I add a new field to user, no one's using it yet. Because no one could have used it yet. It would have been an invalid query. As soon as I add it, people can start using it. So I'm not going to break anyone by adding new things. And I also won't break anyone by changing or deleting new things because I'm not going to do that. I'm going to leave everything on there, and I'm just going to put deprecation notices on the things we don't use anymore. And then we run analytics. We check what fields are being called. And as soon as a field hits 0 usage for a long enough period of time, we know it's safe to get rid of. And so we can kind of avoid the whole versioning problem because we have these other tools that help us know that we're not going to break anyone who is using our API. So that leads us to GraphQL here at Kuali. So by now you know what GraphQL is, you know at least the very basics of how to make a query. Here's how you would send us the query. I know it's transport agnostic. We still chose HTTP because that's familiar with a lot of people. So to send us a query, it'll be a post to this endpoint, like your tenant's URL at /app API v0 GraphQL. And I know I just said GraphQL is not versioned, and then we versioned it with v0. We were new at this. We didn't know what we were doing. So um, we may in the future reroute this URL to get rid of the v0 because we'll never have a v1 or v2. There are no versions here. But yeah, there's that single endpoint. You'll do a post to it, and you'll send us these 4 headers. The content type of application JSON is required. Your auth header is required to authenticate who you are. And then these 2 headers at the bottom, the GraphQL client name and client version, are optional but strongly encouraged. We have a lot of analytics running on our GraphQL server, so we know what queries are being performed, what tenants are hitting those or exercising those queries, what the queries names are, and what client is hitting them. And knowing this really helps us in 2 ways. One is if we deprecate fields, we can keep track of who's still using those fields and contact those people and help them move on to the new ones. And 2, it also helps when debugging issues. If we ever get an issue from someone and they're able to tell us the client name and the operation name that they're using for their query, it really like narrows down the set of data we need to look at to resolve that issue. So it's not required. I highly recommend putting it on anyway. Here's an example of what that would look like, this whole request. Here's a post to my own personal tenant, dallin.kualibuild.com. And an auth token. The name I chose was Dallin's course sync script. All right, that's pretty descriptive. It's going to help debug issues in the future. The body that you would send to this endpoint looks like this. The queries we've been talking about all fit under that last key of query. Even if it's a mutation, it's still under query. Any external variables that you need to add to your query go in that variables key, and then you need that operation name to match the query's operation name. These are actually both optional. Once again, strongly encouraged because they help us track down issues, but they're not needed. And then when you're in the sandbox that we're going to go to next, you often don't use them because it's really easy to just whip out a query without naming it. But once you're in production, you're going to want these. The only place where they are not optional is when you have variables. The GraphQL language forces you to have a name for your query if you're going to have a variable. So back here, profile info, I'm just getting me with ID and name. But here with fetch user, I'm actually taking in an ID and using that ID in my query. So because I'm taking in an ID, I need the name. And then here's also how you set up variables for your query. It's an object keyed by the name that you chose in your query. And you can expect responses that look like this. Like a successful response will give you back a 200, a JSON object with data, and inside data will be all the stuff that you requested. And if you get an error, something goes wrong, you will get a 200. Now that might sound pretty counterintuitive, but you got to remember that GraphQL is transport agnostic. So the errors are displayed in a way that's not like built into HTTP. HTTP is just a transport. The 200 means your request succeeded. Like it was a valid request, we processed it. So GraphQL will return you as much data as we can, and then an errors array of everything that went wrong. So in this case, the your stuff actually worked. So we sent that back to you. And then an error happened somewhere in other. So we nulled that value and sent back an error object telling you what went wrong. So you'll still get back partial responses if an error happens, which is kind of nice. The only exception to this is the 400, which is if you just send us a bad query, we validate those queries ahead of time before we run anything, and we can tell and say, oh, you forgot a curly brace, or you asked for this field which doesn't exist or was misspelled. And we will give you 400, give you the list of errors so you can fix the query and then try again. Or a 401 if you're not logged in. All right. That was a lot of words. Sorry for talking your guys' ears off, but now let's do some demos and actually show show this in action. And we're going to do that at this graphical endpoint. So notice this endpoint is very similar to the GraphQL endpoint you're going to post to, with one character difference. It's GraphIQL. Graphical is a tool developed by Facebook that takes in a GraphQL schema and provides like a really nice sandbox to explore an API. And we will host that for you at your tenant's URL so you can play around with your own APIs. So nope, go back, not there yet. So here is graphical. I'm assuming everyone can still see this because I got this nice green border from Zoom. Thank you, Zoom. So if you go to your tenant's URL at app API v0 GraphIQL, you'll be greeted with this page. And this is a little sandbox for us to hit APIs. It has its own IntelliSense in here. So if you do let's do a basic query, do a query, and we'll ask for the viewer. As I'm typing, you'll see like the stuff pops up. I can go through this, tab complete things. If I hit Control space on Windows, and it's either Command or Alt space on Mac, you can pop up the IntelliSense and see what's available. So I'm going to pull the viewer's ID back, and let's say their action count. And let's go the whole way. Let's get the user. The user itself is going to have more fields available on it. We'll get the user's ID and their display name. Right? And I can run this query by hitting either Control Enter or by clicking on the play button. And the query was resolved, and I got back a response that looks just like my query, which is nice. It worked. Hurrah! Before we go much farther on the queries, I want to show if you were logged in when you came to this page, we automatically set the authorization header for you. So that's why you can make these calls. You are technically logged in. And over here on the right side, there are two tabs. Schema is a representation of the GraphQL schema you are hitting, the schema that we built here at Kuali. And if you're familiar enough with GraphQL, this is a good spot for you to live. You can go look through here and see what's available. Type query is the root of your query. Notice we got viewer off of it. Viewer is going to have its own things on it. If you're not as familiar with GraphQL, the docs section is almost the same thing. It's just a lot more human friendly. And so you can come through here and we'll start with query. There's our query. The query had a viewer. The viewer had a user. The user had a display name, right? You can kind of dive through the whole thing. Some of these things do have details about like a little explanation of what this is. So like here, the viewer represents the current session. And hopefully our plan is to increase that, add more details to all of these types that we've exposed to end users. But right now it's kind of sparse. Sorry about that. But here's how you kind of explore our API, looking through these docs and say, what is available for me to hit? I can query, I can get an app. Sweet. What does an app have? Okay, an app has documents. Sweet. Has a document. What's in a document? Document has a workflow. Right, you can dig in through there. Yeah. I will note, if you try to do a second query here, so you try to do a query like this and run that, notice they're both unnamed. They're both anonymous queries. So if I try to Control Enter and run that won't go away. That's cool. I'll get an error saying, basically, I actually sent both of these queries to the GraphQL server, and the GraphQL server didn't know which one to run. So it's saying, hey, you have to have names for everything. So if I call this like my viewer, and this one down here is viewer 2. Now, if I run it, I can actually send viewer or viewer 2, and GraphQL knows which one I'm trying to run. So you can have as many queries and mutations as you want in here. Just got to make sure to name them all, as long as if you have more than one. Yeah, this is how a query worked. I want to show you how variables and mutations work here. So if we wanted to create our own new app, we might have a mutation called create app, and we're going to call create app tile. Create app itself is deprecated right now. It was how we created apps in the past when they had pictures and photos. But create app tile is how you create a new app that has a color and an icon. And you can see it needs a name, background color, and an icon name. So let's let's tie those all to variables. So to use a variable, it's going to be a $sign and then a name, whatever name you choose. So I want name, I want background color, we'll call that color. And the icon name we'll call icon. And I got to come up to the mutation and assign these things. So name is a required string. Exclamation point means required. And actually all three of these things, color and icon, are all required strings. Yeah. So now our query is set up. We've got the variables tied in. Down here in the bottom left, there's a query variables panel, and it accepts JSON. So you'll have to come in here, create an object, and it'll even have auto like IntelliSense because it knows based on the queries you have in your sandbox what variables are needed to run these queries. So name, we're going to have Katie 2021 demo. For color, we're going to choose a nice orange. And then for icon, we'll use the bicycle SVG. Right. And notice that we have this little red bar on the side. It means our query is not yet valid. If I hover over, we can see create app tile gives us back data. We need to select what data we want back from it. Right. So I look in here, it gives us back all this data. I don't care about most of this stuff. So I probably just want the ID back. Maybe I'll get the name back, and then whether or not it was published. All right. So if I run this, got back our ID and name, and it's not published right now. If I come to my app and refresh this, you'll see here's our KD 2021 demo. So we were able to interact with Build and actually create an app. There's that nice blinding orange color. When you're in here creating a form, I'm getting ahead of myself. Let's go back here. Let's pretend you want to get viewer here, but you also want to get some app. Let's get all the apps, get their IDs and names. Let's run that query. You can see we got the viewer. We also got the apps. Here's all the apps we have. The one I wanted to show you was near the bottom, the KD demo data. So I'll copy that in. And instead of apps, I'm going to get app singular with an ID equal to, let's put it in the variable, app ID. So $app ID is an ID, and app ID we'll list down here is that ID we just copied from down here. So now if I run this, we'll get back just the one app that we care about. An app contains documents. So we want to get the documents off of this app, and we call that document connection. I want to make sure this is clear. We often will give out lists of things in our API, and almost always those lists are in the form of a connection. So instead of just giving you a list of documents, we give you this object that has a list inside of it, but has a spot for other metadata to go. So in this case, the document connection gives you a total count, and it gives you page info, which is like the skip and the limit, and if it has a next or previous page, all the pagination stuff. And then it gives you edges, and that's where the documents actually live. So we've got document connection, so you can have all this metadata. Then the edges, once again, is like this object, and we reserve that object to have more metadata in there about the document itself. Instead of about the connection as a whole, it's about the document. We don't have anything in there yet. So you're just going to look at the node, and the node itself is the document. So a connection will have edges will have nodes. Nodes is the thing you probably care about. So here we can get the documents, say their ID and their data. So if I run this, you'll see this is a pretty neat thing actually. I was able to get, come to that in a second. Got our app. We had 4 documents in here. Here's the first document. Here's its ID. We had a name, a bio, favorite food, right? And all these have really pretty labels. Those pretty labels come from when you're building out your form and you add a data field, there's this unique JSON key in the bottom. If you set that, so maybe we'll call this thing name, we'll set the JSON key to name, And we'll also have a description, set the key to description. As long as you set that key, then when you're using the API, you'll see that key in the data. So it'll be a lot easier to tell what is what. If you forget to set that key, you'll get just our unique ID. And you can see that if you pass the key by argument into your document connection, key by ID, that the data actually is stored like this, right? Dallin is stored under ML8DJ underscore XNIR, which is, that's a slightly less readable than name. So as long as you set that custom key, you're fine. If you forget to set it, the best way to fix that is to go set it. But if there's some reason you cannot, you can always come into this document, right? Right now we're fetching the ID and the data. We can also fetch the form for that document. The form has a schema. That schema itself has a form key, a type, a label, details. And if we fetch this back, you can see for this document, I've got the schema, and here's a text field called name. The form key matches up to this key over here. So it's not as easy, but you can kind of do this like matching and say, oh, yep, JS9Y does match this one up here. So this text area called bio must have been engineer at Kuali Build, right? And then the cool thing here, I was almost ahead of myself before, is we just fetched an app, and we fetched those apps documents, and for every document we fetched a form. Like that, it still just blows me away every time that we just fetched 3 resources that were all connected, and they're all even stored in a nice way of like the documents are inside the app, the form are inside the documents, and it's a thing that would have taken multiple requests back in the REST world, and would have taken a lot of stitching together to get it all working correctly. And we got all those things connected and just the data we wanted from those things. Got a little bit of time left. So this is graphical. This is where you probably spend most of your time like playing with the API, learning about it over here in the docs tab and just trying out different things. This is hitting the actual API. So if you're in your like production instance, you're fine to do queries. Just be really careful if you're going to do mutations because you are editing and updating live data. But after you've experimented here, you probably want to move this to your own tool, your own either script or tool to fetch data. I'm going to demo Postman. Postman is an online like API tool. Helps you do generic requests, kind of like a curl, but with a nice UI around it. You're either going to want to use Postman, or you'll probably want to use your own like Axios or Python request or whatever library you're using. But we'll make a request, a GraphQL request using this tool. So I want to take this endpoint, the GraphQL endpoint we're hitting, and we're going to do a post to that. We got to go into the headers, and the required headers were content type. Oops. Of application JSON and an authorization bearer, and I need a token. So you can copy this token in here if you want. That is your session token. If you ever log out, that token gets invalidated. The way you probably want to do it if you're building an actual script or integration is you're going to want to come to your user profile, go to the API keys section, create a key. This is for the KD 2021 demo. There's my key. Don't steal it. Don't worry, I'm going to revoke it right after this. And it's my own like developer instance, so there's nothing real in there anyway. We'll paste that key in here. And so now those are all the required headers you need. And then you need a post body. Some tools will actually have native GraphQL support. So this one actually does. So if I come in here and let's copy this query, I can just paste this query right in here, the native GraphQL support area. You know what? To show this off, I'm going to want a much smaller query. You'll see why in a second. Let's do this dinky little viewer 2 query. So if I do this and I send it off, I actually get back this data, right? We'll do, was it viewer and display name? Nope, there's our error. Got a 200 with, oh, it's 400 because of bad request because the display name it knew was not on here. But we do have action count. We'll do that, make our query a little more interesting. So my viewer, my currently logged in user, has 52 open actions. Odds are you're not going to have native GraphQL support in whatever tool you're using. So you're going to want to use raw, just plain JSON, and write out the JSON that we talked about in the slides. So you've got an operation name, you've got variables, and then you've got your query. So here's where you'd paste that query in, right? And it has to be on a single line. This is why we do it with a small query instead of that massive query, because I don't want to put that massive query on a single line. And then our operation name needs to be the same as our query operation name. And now if we send this, we get back the exact same thing. Let's take out ID so you can see it actually change. Right, so this is how you'd actually take a query that you've built in the playground. You copy it over to your own tool, and here's how you kind of format it so you can actually run it. And I think we're out of time. So I'm sorry, I know that was a lot. Luckily, this is recorded so you can go back and watch it. But that hopefully tells you why we chose GraphQL, what things we thought were good about it, how to play around with our API and learn more about it, and then how to actually hit the API. That's everything I've got.
Looks like JD might have a question.
Yeah, I had one quick question about, well, first of all, thank you for the key by ID thing. I had done a quick GraphQL call to try to get the documents list off of one of our apps, and I wasn't getting the custom JSON keys, and it's because I had that in there, so that was really helpful.
Okay, awesome.
My question is exactly about this, tools not having native GraphQL support and that query string being like really long and ugly. Or like, are all those tabs and new lines and so on and so forth actually required in the query, or do you just have to have some kind of object structure? Like if you were to go back and share your screen and do copy curl on one of those longer commands, you would see like just how long and kind of nasty those can be.
Mm-hmm.
And is it okay to trim out all that extra fluff in there and still have the query execute?
So almost every piece of white space is optional. So all the tabs, white space, new lines. I believe the only place that it is required is like obviously between each field, you need at least one space. And then at the very beginning where you have query space, your operation name, those can't be joined. So I guess use common sense there. Like, how do you describe that? No, the white space is pretty much optional.
Got it. Thank you.
Is that what you're asking? Does that help?
Yes, definitely. Because they just get really long and thorny
They do.
with the longer queries. Okay, perfect. Thanks.
Yeah.
I'd ask a question. How long, can you tell us about how we use GraphQL in the build application itself?
About how we use it?
Yeah, and how long we've been doing that?
We started introducing it. I'm really bad at time. I think it was like 2 years ago. And as of, I think a year ago, we actually got rid of our REST client. So we only use GraphQL in the build client. And yeah, the queries we were just writing in the GraphQL sandbox, we'll copy paste those into our app and leave all the white space in there. And so you can kind of look at the query and say, okay, here's the data I'm going to get back. And then you look at the component right above it and know that you have that data available to you. And then we have a bunch of ESLint plugins that lint through our code, make sure the queries are valid. And then they also make sure that the data we're using in our components was fetched by the query. So we get like a lot more guarantees and safety when coding with GraphQL. And it's a lot easier for new developers to onboard and see like all the data in that component. They know what they're getting into. Does that help answer that question, Tad?
So Dallin Cameron has a question. He says, what comes back for an attachment on a document?
That's a great question. The attachment, today, the attachment will come back with just a URL, and you will have to hit that URL to go download the attachment. So
Yeah, it contains a bunch of information for accessing the document from Amazon, right?
yeah, I think the URL is actually all signed and ready to go. Like the attachment will have the content type and the content length and other things, but the URL is the important piece to hit.
And that URL is behind authentication too, but
Yeah,
it's signed, ready to go.
I guess that's one piece we didn't really touch on with GraphQL is there are definitely spots where it's not good to use GraphQL. And one of those is like large objects, so attachments. We will probably always have separate URLs for our attachments. They just don't really fit well in GraphQL responses. And then the other one is streaming large data sets is also not great. So like if you're going to generate a CSV, you're probably going to have that always be over plain HTTP and not over GraphQL.
I have a question. Do the build integrations, are there plans to, or do they currently support GraphQL? You know, like for example, in Kuali Research, there is a GraphQL endpoint to get some data. Is it possible to use that to create an integration in a build form to pull data in?
Yeah. So today the integrations are pretty basic, but you can choose to do a post to an endpoint, right? And nope, just kidding. You cannot specify the post body, so you can't actually put the query in. So today, no, you cannot hit GraphQL endpoints with build integrations, but we are working pretty hard on a replacement for that, like not a replacement, but like a new set of integrations that you can build that will make it really easy to make GraphQL calls. We got no timeline on when that's coming out. I'm sorry.
Thank you. Thanks for answering.
Hi, this is John. I had the same question, so thanks, Zach, for asking that. So just in general, so is GraphQL, just in terms of, I'm thinking use cases, if you're trying to pull like stats and reports off apps, like how many submissions we have, what are some of the details to kind of do some reporting off that data? Is that typically the most common use case, or I don't know if you have a couple you could just rattle off, like, yeah, we see customers do these 3 things commonly. It seems to benefit them.
I think the most common one I've seen so far is that they're pulling the document data. They want to pull updates of that to push in and update into other systems like a data warehouse or something like that. So they're like pulling the newest items since last updated, that type of thing. I bet JD's got other ways they're using it.
We've used it to clone and migrate apps before that was a native feature in the platform, because the app node has this relationship, this tree that contains all information about the app. And so we would grab like the form node and the workflow node, and we would copy that from one environment and post it to another environment. And it worked beautifully. Like I said, I have this use case now where we grab the document list off a given app. We have our registrar has this course schedule that's going online soon, and they want to be able to have messages appear at the top of it. And we're just using a Kuali app as a quasi CMS or quasi backend for that, just pulling the documents list of message submissions and taking an Azure function app that grabs that with a GraphQL endpoint and presents it to this serverless page hosted in GitHub Pages. So anything you would do with a normal API, you can do with GraphQL, it seems. We've just grown accustomed to it because, Kuali's been migrating in that direction.
Awesome, thank you.
I will also note, like, if you're exploring the API and you notice that there's stuff missing, like you do want some kind of stat on an app that's not there, file an issue and we'll get it out there. Like, we know that the API is not 100% complete yet, but we'd like to get more use out of it, more usefulness in it.
Okay. First of all, Dallin, thank you so much. I just wanted to remind everyone of the contest to win a free build app that is available to get in on that contest until the end of the week. So if you haven't already, please make sure you do. And then also, as a reminder, please make sure you rate the session. That helps us know what kind of content to bring back next year. You can do that by clicking the Rate Now button at the top of your session screen. Other than that, thank you so much for attending. Recordings will be available of the build session sometime in the next week. They will be, I'm told, available through the Socio app. So just a heads up. Have a great day. We will see you tomorrow. We start a little bit earlier tomorrow at 10 o'clock Mountain if you're interested in the student build session at that time. And we'll see you tomorrow. Thanks, everybody.